All right, so today's notes are provided notes. It's in the packet. Unit 5, solving equation notes. If we're keeping track of days, this is day 5, I think. Five types. You kind of know what you need to know in order to do these. So there's nothing new like concept-wise. So we're just going to work a bunch of examples together. There's 5 types. I wish I had labeled these 1, 2, 3, 4, 5 as we go, but you get the idea. First type, exponential, but exponential that have the same base, or at least could have the same base. So the easiest problem we'll have, or the easiest type of problem we'll have, is one like number 1. So it's an exponent equation, yes, but if it's 3 to something equals 3 to something, well, I'm pretty sure the somethings have to be equal to each other. That's the only way this is going to work. So we like these type of problems. If the bases are the same, you can just grab the exponents and set the exponents equal to each other. And now we've got an algebra 1 equation to solve. So x equals 5. That's our favorite type. We like that type. By the way, as with almost any equations, you can check these if you want to, and you will have a calculator. So I wouldn't check them till the end, but if you wanted to, 3 to the 5 plus 2 is that. 3 to the 3 times 5 minus 8 is that. So I know I got the problem right. One so simple, you're probably not going to check, but we'll get to some that are a little bit harder that you might want to check. All right, still in the Roman numeral 1, they either have the same base or you can make them into the same base. Well, number 2, it's not the same base, but is there a way I could rewrite 8? It is 2 times 2 times 2. Could I write it with an exponent? 2 cubed. So in place of the 8, I'm going to write 2 cubed. I need to be careful that x is still there. So I replaced 8 with 2 cubed. Let's see, power to a power we multiply, so that becomes 2 to the 3x equals 2 to the x plus 1. And now it's exactly like number 1. You got the same base, so you can grab the exponents and set them equal to each other. And solve yourself a nice little algebra 1 equation there. And again, you have a calculator if you want to check. So I'm going to plug it back in. 8 to the 1/2. Is that weird decimal? Maybe that makes me a little nervous, but let's plug in the other side and see if we get the same weird decimal. 2 to the 1/2 plus 1. Oh, same weird decimal. So I feel confident about my answer. So when it comes test time, I don't know that I would check them all as you go. I don't, timing might be an issue, although it's a block day test, so you're probably okay. But if as you're working the test, if you hit one that you're like, ooh, not sure about that one, we'll put a star next to it, and when you get to the end, go back and check them. Or if you know you got lots of time, go back and check them all just to make sure. All right, for the next Roman numeral, any questions on those? That's like the easy one. We like those. For type number 2, exponent equations, but not the same base. The only way to do these is must have a calculator. So if you don't have a calculator with you, or go pull one up online, pause the video right now, go get one, or go find one online and then resume the video. All right, so hopefully you've grabbed a calculator. This example here is kind of on the harder end of things, so I want to work an easier one. I don't know what to number it because we're out of 3.5, but it needs to come before 3.
2.5.
Then it looks like it's in the previous section, but whatever. We'll call it 2.5. So question number 2.5. We're going to do this one first. You can see right away that it's, even without knowing how to do it, you could guess that it's easier than number 3. So you're right. You're thinking right. Like, well, can I make these have the same base? Because then this would be an easy problem. If I could rewrite 13 as 5 to something, that'd be great. 13 is not 5 to something. In fact, you said it was prime, which is good. That means there's nothing you could rewrite 13 as. So you're kind of stuck with 13. 5's the same thing. I can't rewrite 5 as anything. So we're sort of stuck, which is why this is in a whole separate class of problem than Roman numeral 1. So here's the trick with these. We're going to end up using a property we talked about yesterday. The list of things that you can do to both sides of an equation to solve it is getting longer and longer. Like when we first did this in Algebra 1, we're like, look, you can add 5 to both sides. Isn't that amazing? And then you did, 15 equations where all you did was add 3 to both sides or subtract 2 to both sides. And then the next day in Algebra 1 class, your teacher's like, now we're going to divide both sides by 2. Isn't that amazing? Oh, let's do 15 problems like that. A little later, you maybe square rooted both sides, something a little bit different. Today, we're going to natural log both sides. So I'm going to take the natural log of both sides. And your initial reaction might be, well, that just really gums up the works here. Like, why would I do that? Well, there's one significant advantage to doing that. Do you know what it is? It uses a property we learned yesterday. Not the E thing. What can I do with 2x plus 1 now? I don't want to fish hook it, but I can put the 2x plus 1 in front. And so then I don't even have a exponent problem anymore. Right? There's no exponents in that problem. There's natural logs, which we don't really like, but natural log of 13 and natural log of 5, those are just numbers. So I can use my basic algebra to solve this. Like, natural logs are ugly, but that's why you got a calculator for. So let's solve this for x using our algebra skills, and then we'll go to the calculator last. So to start to get x by itself, some people are tempted to distribute the natural log 5. And that would be one way to do it. But the easier way to do it would be to start to peel the pieces off to get x by itself. Any idea what we could do? Yeah, let's divide both sides because I want to get it out of the way. It's going to mess up the other side, but I don't care about the other side. I want to get x by itself. And I'm going to use a calculator anyway, so even if the other side starts to get ugly, who cares? The calculator can handle ugly. So 2x plus 1 equals natural log of 13 divided by natural log of 5. Which is kind of ugly. Don't go to the calculator yet. So ignore that side for a minute. On the left-hand side, this is like Algebra 1 level stuff. Give me the 2 steps we should take to get x by itself. Yeah. If you got 2x plus 1 on this side, let's subtract 1 and then divide by 2. So yeah, this side's kind of ugly, but no big deal. I'm going to subtract 1 and then divide by 2. So subtract 1 and then divide by 2. So that's quite a mouthful for an answer right there. but calculator can handle it. Whether you put it all in at once or not is up to you. I don't know that I would put it all in at once. I might put it in piece by piece here. Also be careful when you press log or natural log, it automatically opens the parentheses, which means you have to be responsible for closing the parentheses. So natural log of 13, close parentheses, divided by natural log of 5. And then where do I want to press enter or keep going? I think I'll do -1, then enter, then divide by 2. It's 0.297. Usually we go 3 decimal places, mainly because AP test is 3 decimal places. All right, well, this was an ugly problem, so I would definitely want to check this one. Like those first 2 problems, I probably would not check those on a test. I trust myself. Here, we did a lot of stuff, and not just algebra stuff, but we also had to make sure we put things in the calculator correctly. So I'm going to go back to the top and plug in x. Whoops, where'd it go? There it is, 0.297. So 5 to the 2 times 0.297 plus 1 is supposed to be 13, and it's pretty close because of rounding. So I feel good about my answer. So the big thing for Roman numeral 2 is to natural log both sides. Yes. If you use the answer key, or if you could also scroll up there and get it. 5 to that times 2 plus 1, that should be exactly 13. And it is. So if you don't like the rounding thing, you can check it all the way out there if you want to. All right, number 3. Well, same process, although it's going to be a little bit uglier because there's exponents on both sides. Natural log both sides. Bring the exponent down. This one's harder than the last one because the last one only had one x in it, so I could move things around and start to get the x by itself. Here I got x's on both sides. Okay, so yes, your motivation is right. Like the idea is I need to get the x's on one side and the not x's on the other side. That part is correct. But if I divide by natural log 2 to get it over here, that would be fine. If I divide by 1 minus x, I'm going to make more of a mess over here than is worth it. So the motivation is correct. I want to get the x's by themselves and the not x's by themselves. But I want to do that with adding and subtracting. So I am going to have to distribute on this one. So it's not bad. Just multiply everything by natural log 2 and everything by natural log 3. And then now, Andrew, your motivation will work a little better. Your end goal to get the x's by themselves and the not x's on the other side. So now to get this x to the left, I'll add it over. And for this one, I'll add it over. So 4x natural log 2 plus x natural log 3 equals natural log 3 plus natural log 2. Remember, natural log 2 and natural log 3 are just numbers. They're not nice numbers, but they're just numbers. There's nothing magical about those. Not recommended, but I suppose you could put them in the calculator and then just carry 3 or 4 decimals as you work the problem. But it's easier to just write ln2 than 0.693147. So leave it in terms of natural log, but realize that those are just numbers over there, and your calculator is going to handle it in a minute. It can handle it. The calculator can. I don't know if you can, but the calculator can. Any idea on what we want to do next? I've underlined the 2 x's as an attempted hint. Nobody does this with simple things. You just say 5x plus 3x is 8x. But what your brain did without you even realizing it is you factored out the x. That left 5 plus 3, and then you know that 5 plus 3 is 8. Now, nobody shows this step, right? Like, nobody shows that step. There's no need to show that step. Your brain just said, okay, I can put the x to the side, add the 5 and the 3, and then put the x back on it. And your brain did it so fast you didn't even think about it. Well, we're going to do the same thing here, but it's a little more complicated, so we have to think about it a little bit. I'm going to pull the x out, set it aside, and add what's left. That's a whole lot more complicated than 5x plus 3x, but it's kind of the same thing. Hold the x to the side, add the other numbers. I mean, I can combine 5 and 3. I can't really combine these, but it's the same process. Speaking of same process, I've got x times a number equals another number. Let's just say this was x times 7 equals 12. What would you do to get x by itself? By? Yeah, you divide by 7. So this is an ugly, complicated number, but it's still the same process. It's the same thing as dividing by 7. Both sides are a little more complicated than 12 and 7, but there's my answer. And honestly, I would be okay if you left that answer, because that's an exact answer. Now, most of you are not really comfortable with that. You're going to super careful with parentheses. Natural log 3 plus natural log 2, all in parentheses. In fact, if you want to hit enter there, you could. Divided by parentheses, because I want to make sure I divide by all of this stuff. 4 natural log 2, close parentheses on the 2, plus natural log 3, close on the 3, and then close on the denominator. X equals 0.463. And this would be a great one to check, because that was a whole lot of algebra. So strongly recommend you check on these. By the way, are you guys familiar with the answer button on the calculator? It's fabulous. It means you don't have to type in 0.462843347 whenever you want to use it. You hit second, and then the negative button says answer, and so it'll use that. -1. So the left-hand side is 1.804. The other side, 3 to the 1 minus, although be careful, I can't use answer here because it would be that answer. I'll scroll up and go get the 0.463. And here's the moment of truth. I better get 1.804. Yes, I did it right. Strongly recommend you check these crazy ones. In my mind, that's the hardest of the bunch. So that's Roman numeral 2. There's 3 more to go, but that's the worst of the group. Well, we got to do all 5 today. All 5 types. And we're on 3. They're going to go a little bit faster now. I think 2 is the hardest, 3 is the second hardest, and then 4 and 5 are pretty easy. Oh, Roman numeral 3. 4 to the x minus 6 times 2 to the x. Again, sometimes the computer and printer don't talk to each other, so the printer freaks out and just puts the box there. This is I'm going to move the 8 over, mainly because it says with factoring, so that suggests it should look like a factoring problem. No one's going to tell me that 6 times 2 to the x is 12 to the x, right? We're not going to do that. No one's going to do that, because exponents have to come before multiplication. What's a different way I could write 4, especially looking at the rest of this problem? 2 times 2, or I could write it as 2 squared. So I've got 2 to the 2x minus 6 times 2 to the x plus 8 equals 0. Some people will factor that as is. I want to do a little bit of a trick. And a trick that we use a ton in calculus. I want to let u be that middle term, that 2 to the x term. I'm going to switch things around a little bit. Did you do this last year? Some of you were saying yes. So some of you are like, I kind of know. I've seen this before. We've done this. So this part's easy, or easier. How could I, what's this going to be? U squared. If I square u, I would get 2 to the 2x. So we do, but we have easier letters. So yes, we have more letters, but it's a lot easier to work with factoring this than factoring exponent stuff. So u minus 4 and u minus 2. U equals 4, u equals 2. Easy peasy stuff. Except that this problem didn't start as a u problem, it started as an x problem. Whoops.
Shouldn't one of those used be 4?
Yes, one of those u's should be a 4. Say that again?
Let's make it back into a u problem.
You have to put it back into the 2x. So she said make it back into a u problem. Let's make it back into a x problem. And I can do that because u is 2 to the x. Oh, this one worked out kind of nice. If 2 to the x equals 4, then x equals 2. I don't have to, I thought I was going to have to like natural log both sides, but this one worked out.
My God. Is that it?
And that's it. We could check them if you want, but Tired of checking. They work. More U substitution. This is the last hard one. We're downhill from here. I promise. Oh. What should we let U be? E to the x. Good. E to the x. I mean, E is a number, but I'd rather write E than 2.718281828 and on and on and on. So let's just leave it as E. What's e to the 2x going to be?
E squared.
U squared.
Me too. They're literally Oh, I have to go to an even worse part.
It's got to be 2u and u. I hope everybody can factor by now. Let's see. Signs, they both have to be the same sign, but they both have to be negative. And I think if I put the 4 across from the 2, that gets me 8. And 1 makes 9. So that means u equals 1/2. And u equals 4. But this wasn't a u problem, this was an x problem. The u's are just helping us along the way here. So in place of u, I can put e to the x. And so now I want to natural log everything right now. But this is an easy one. Do you remember what natural log of e is? Actually, if you don't, it's fine. You got a calculator. The natural log of e is 1. The natural log of 1/2. Yeah, I don't know that one off the top of my head. E to the what is 1/2? Well, of course it's 0.693, negative 0.693 from the calculator.
Wait, why is it negative? That doesn't make sense.
A negative makes it flip over. That's why the answer is negative.
Okay. I thought it was natural log.
Natural log of 1/2 is negative 0.693. We got to do the other one here. Again, we're natural logging both sides to get that x out of the exponent. And natural log of e is 1, so even if you don't know that and you type it into the calculator, you'll still be fine. The calculator knows what the natural log of e is. So, I mean, if you need to, that's not really necessary, but there it is. 1.386. In the interest of time, I'm not going to check them, but it would be easy to plug them back in and see if they worked. Check them if you want to. Okay, a little bit of background before we finish up with type 4 and 5. Again, these are easy types. But you can't take the log of anything less than 0. whatever's in the parentheses, whatever you're taking the log of, has to be greater than 0. This is very much related to the domain and the graph of logs. Right? There's an asymptote. In fact, it mentions the asymptote. And everything was always like to the right of the asymptote. There was nothing on the other side of the asymptote because you can't take the log of a negative number. So on the log equations, you have to check. You got to check your answers. All right, I like this one. This is a log on each side. So let's condense. And it's going to turn into an easy problem after we condense. So how do we condense if we have two logs that are added? Multiply. So natural log of x times 6x minus 1 equals natural log of 4 to the 1/2. But once you have natural log of something equals natural log of something, I don't want to say you cancel the natural log because that's not quite accurate, but it does mean that the two somethings have to be equal. This was sort of like type 1 where we had e to something equals e to something. You can grab the two somethings. Same thing here. The two somethings have to be equal to each other. What's 4 to the 1/2, by the way? Square root of 4 is 2. So now we have a quadratic equation, meaning we'll set it equal to 0 and solve from there. Hopefully it factors. Probably shouldn't say this on camera, but our calculus students had a few problems like that on their test, and some of them whiffed it big time. They tried to solve from there rather than moving the 2 over and factoring. So they'll have a warm-up on that today. Okay, I'm going to switch to a pencil because I don't know the answer. I'm going to have to do some guess and check. It's got to be 1 and 2 to get to 2. Signs are different. Again, I'm writing in pencil now because I may have to switch up my guesses here. To get to 6, I can use 1 and 6 or 3 and 2. I think if I put the 2 across from the 2 and a 3 across from the 1, I think I got it the first time. Who needs a pencil? I'm good. So x equals 2/3 and x equals negative 1/2. Okay with that?
Yeah. I'm okay with it.
Those are the answers, but I have to check to see if I'm taking the log of a negative number. So I go back up to the top. Natural log of x, natural log of 6x minus 1. That's what I'm worried about. So if I check 2/3, natural log of 2/3 is okay. I don't know what it is, but it's not negative, so 6 times 2/3 minus 1. Let's see, 2/3 of 6 is 4. 4 minus 1 is 3, so that's fine. Again, all I'm checking is to make sure I'm not taking the log of a negative number. So 2/3 works. Of course, you could check it all the way into the original and just make sure your answer works. That would be another way to go. Whoops, natural log of 1/2, that won't work. So even before I do anything else, that one's done. I'm plugged them into the original equation to check to see if I'm taking the log of a negative number. Number 5, and final. Log on one side only. So Roman numeral 4 we had to condense. Roman numeral 5 we will have to condense. Let's see, if we're adding logs, how do we condense? How do I condense those two? Multiply them. Now, this one is not like the last one. The last one, it was log of something equals log of something, so I could just kind of cancel the logs and be fine. I don't have that situation here. So how did we handle log equations from a couple days ago? Some of you have said this word a few times today, just not in the right spot yet. Fishhook, making an exponent. So 10 to the first equals x minus 1 times x plus 2. X squared, let's see, plus x minus 2. Don't factor and set it, this is, the setting the factors equal to the other side only works if the other side is 0. So don't tell me x minus 1 equals 10 and x plus 2 equals 10. That's terrible. I don't know what to say other than I will make fun of you, not to your face, but just personally. Maybe to the other math teachers, yes. So let's move the 10 over. And what do you know? It factors. Oops. Except I factored it wrong. No, I had it factored right in the first place. X plus 4 and x minus 3. So x equals negative 4 and x equals 3. But any log equation I have to check to see if I'm taking the log of a negative number. Log of negative 4 minus 1. Well, that's not going to work. That's the log of negative 5. So negative 4 is out. If I try 3 minus 1, log of 3 plus 2. That's positive. So we're good with x equals 3. Log equations, you got to check. You got to check them. All right, today's assignment is worksheet worksheet 6. Please flip the page. I will post the odd ones momentarily. Up through number 16. So Friday's assignment is 1 through 16. You can probably guess what Monday's assignment will be. The rest of them. So I'll post the odd ones. I don't think they're posted yet, but I will eventually post the odd ones. So a lot of pieces today, but I don't think any of them are that hard. It's just there's a lot of stuff going on. So try those. We'll go over on Monday. There's nothing new concept-wise Monday, so we'll get a little more practice. And then Tuesday is review, and then block day is test.